Welcome, John Boik, PhD, to the fourth Active Inference Symposium. We're really pleased to have you here and looking forward to your session, CogNarr Ecosystem, Facilitating Group Cognition at Scale. And over to you.
All right, thanks, Ian. Again, my name is John Boik. I'm a fellow at the Active Inference Institute. And I will be talking about the CogNarr ecosystem to facilitate cognition at scale, as Ian said. I do want to say that the links for this, there's a bunch of links on the Institute project page. I think these slides will eventually be made public, but in the meantime, if you're interested, you can just simply search on CogNarr and Coda, or CogNarr and my last name, Boik, and you'll find the Institute project page. There's lots of links there. All right, so what is the CogNarr ecosystem? CogNarr means cognitive narrative. And in concept, it's an open source, online, extensible ecosystem, technologies, tools, libraries to facilitate group cognition, especially for large groups. And although there are many, many use cases, the use case that one of the prime use cases is deliberation, strategizing, collective problem solving, and decision making in the large group setting. CogNarr essentially helps, what I like to say is it helps users to tell their story. That is, convey their beliefs to a group about how the world works relative to some situation. And even more specifically, convey their belief model to a group, make the belief model explicit and transparent to the group. So they might answer or address questions like, what's the problem or situation? What happened? How did it happen? What might happen next? Why did it happen? Who does it affect? Who does it involve? What does it mean? What should be done? What can be learned? All of these kinds of questions. CogNarr allows users to tell a rich story. And by rich, I mean potentially long, complex, nuanced, dynamic, conditional, quite different, in comparison, quite different from some kind of online collaborative architecture that, for example, asks you to a yes or no question, or asks you to give a thumbs up or thumbs down on some issue. No, this CogNarr will allow a user to convey very rich information. And there's a back-end computational system that assists the digestion of that information so that the group can better understand the many different stories. So the computational system assists and guides users in constructing stories, helps the group digest the information, make sense of it, assesses stories for their quality. You know, is the story on topic? Is it comprehensible? That kind of thing. And then the backend system also performs inference for queries that various group members might have about a story or for a storyteller. It is important to say that the computational system does not predict the future. That is, it's not going, if a bunch of people, if the issue at hand, say, is garbage collection in a local community, the computational system is not going to assess stories and then predict which of them is most realistic. That's not really its purpose. What its purpose is to convey, to make transparent and explicit the beliefs of members. And the members, when they create their story, when they tell their story, they include what they think will happen in the future. The users make predictions. And also the group assesses the realism then of any of the stories that are submitted. So what is a CogNarr group? A group is a set of people that sense their world, process information, anticipate outcomes, evaluate options, make decisions. And in other words, we can think of a group as an organism that performs cognition. And then the question is what design of CogNarr might actually facilitate functional cognition as opposed to dysfunctional cognition. So examples of groups could be, every group, informal group who like polka dot shirts, a social club, volunteer groups, civic organizations, professional groups, corporations, nonprofits, political entities such as cities, and more. So groups can range from formal to informal, flexible to structured, temporary to permanent, small to large, autocratic to democratic. The platform is really a tool that can be used for many use cases by many kinds of groups for many purposes. There are, of course, some rules to keep it all functional and transparent. And when I say large group, what does that mean? Often in the literature, when they talk about a large group deliberation and cognition, they might be thinking of dozens of people, but here we're thinking about perhaps dozens, hundreds, thousands, millions. This should scale up to cities, states, and perhaps even a nation. Who knows? If I should say, if CogNarr were ever built, if it works as advertised, this is all possible. And maybe I should also say, at the moment, this is just I've published I've posted two articles on CogNarr so far, 2 research articles, and that's all that's been done. So this is at the beginning. This is a vision, really, of what this could be. I'm presenting a vision. So the question is, what kind of design for CogNarr would allow some large group, say 100,000 people, to gather online synchronously or asynchronously and share the potentially complex dynamic belief models about some situation? How could that be done? That's the question here. And obviously I have some ideas on how that could be done. So, but first, maybe I should say that the CogNarr project is inspired by active inference, and in particular, active inference from the vantage point of this project, active inference provides a description of functional cognition. That is, as I think everyone probably knows by now, watching the seminar, that cognition, we can idealize it as maybe a 4-part cyclic process of predict, act, sense, and learn, and it involves many components. For example, memory, recall, attention, and the entire picture of that process can be, as it plays out in a human or an agent, it could be either functional or dysfunctional. For example, an agent that it cannot predict the future with accuracy is going to make decisions that are suboptimal in general, typically. So that would be an example of dysfunctional cognition. If you can't remember what happened, or you can't predict accurately what's going to happen in the future, those would all be indicative of dysfunctional cognition. So in active inference, an agent favors choices that ensure the greatest resolution of uncertainty under the constraints as preferred outcomes are realized. And all of that provides a framework such that the components of cognition could be recognized, and each component can be focused on as a design element, and the process of cognition in any group could be assessed, whether that is a functional or dysfunctional or somewheres in between. And of course, that would be a multi-valued scale. So what is CogNarr really? CogNarr essentially is designed to be part of the cognitive architecture of the group that is using it. That any organism that performs cognition has some kind of cognitive architecture. For an animal, that is, involves a nervous system. It involves, for a human, it can involve external objects such as computers and tools. And for a group, it includes a set of norms, rules, mechanisms, institutions, sensors, analytic processes, systems, and any other procedures that facilitate or guide cognition. And then CogNarr is obviously designed to be a component of the cognitive architecture of the group that uses it. And viewed differently, and I'll talk about this more in a moment, CogNarr technology provides a means to digitize and make explicit a person or an agent's belief model. And in that sense, some of the technology behind CogNarr could be used far beyond CogNarr. Could be used in medicine, psychology, and unlimited number of other applications of how you would take an agent or a person's belief model, make that explicit in a way that computation can occur, and include that into some kind of inference models or generative models. So CogNarr stems from some past work that I've done. And it's this past work, the CogNarr and this past work are related in that all of it is about cognitive architectures. In the past work, I was looking at social systems as cognitive architectures. And by social systems, I mean economic systems, financial systems, governance systems. I view those core societal systems as a means, as a part of the cognitive architecture of the society that is using them. That is, we think through our governance systems, we think through our economic systems, we make decisions that affect our world through our economic system, for example. And the previous projects asked this question: out of all conceivable societal systems designs, and I don't mean conceivable in, capitalism and socialism and the way it's been implemented in the past. What I mean is like blank slate. Out of all conceivable designs for economic, financial governance systems, which ones might be most fit for purpose? And that purpose is cognition in the active inference set. So reduction of uncertainty, accurate prediction of the future, attaining those conditions that allow for thriving of the population, those things. And I propose in this past work a path, really, of how such a project could be implemented, how, what it would do, how it would go, how would you test new systems, and so on. So I referred to this earlier work. And again, the links are all on the CogNarr project page, if you can find that. All right, so what is maybe the core element of CogNarr is what I call a story graph, and essentially it's a meaning representation. It's the explicit representation of a user's belief model. And this, of course, is a very difficult problem to solve. How do you take some belief model that is in say the mind of a person and put that down on paper, so to speak, such that computation can occur with it, inference can occur with it? This is a very, very tough problem, but I think there's possible ways to move forward with it. I think I mentioned, or I should mention, that there was 2 papers published on CogNarr. The first paper is more of an introduction, overview. The second paper is really all about, it focuses on the potential meaning representations. So story graph is the sort of the core innovation on which CogNarr is based, and its story graphs are used to curate, understand, reason with, conduct inference on high quality information about human experiences, beliefs, and expectations. And essentially the way it works is a user might type in or say some passage, a few sentences perhaps, a thought, and that passage would be translated into what I call a story graph fragment, just a small little graph, a meaning graph. And that little fragment would then, the system would merge that fragment into the growing story graph, the overall story graph. And then eventually by inputting passages or after passages, the story graph gets built up, the meaning representation gets built up. And then once it's complete, or once it's almost complete, then it can be translated into alternative meaning representations that might be appropriate for various, logical models or other kinds of models, probabilistic models. Can can maybe be translated more directly into some types of probabilistic models, and could also be translated into a natural language. So in time, eventually, if CogNarr is successful over time, it should be possible to have the system read back your story. Like, tell me, read this back to me, and let me make sure that it's what I'm intending it to be. Even in the far future, it might be possible to make animations as an output of this, a little movie of this is what I think happened, and this is what I think will happen in the future. So what is a meaning representation? I have a picture here of a abstract meaning representation. That's a very common one used in the research world. In natural language inference, there's in the research world, there's lots of different types of meaning representations. This is just one of them I'm using as an example. And this is for a story, a sentence. A similar technique is almost always impossible to apply to other crops, such as cotton, soybeans, and rice. And you can just, I won't go into detail about this, but you can kind of see that there's a graph and various words are connected to each other. Ideas are connected to each other. Concepts are connected to each other. And this kind of meaning representation is used throughout research. And the story graph, you can think of a story graph as a much more complex version of this. It consists of layers. One layer might be predictions that the story is making about the future. That could be one layer. But a story graph is actually more like, instead of this sort of static picture like this, static graph, a story graph is really more like a movie. It's a evolving graph path, really. And it involves high dimensional vectors of word meaning. So it's far more complicated than this, but this gives you a really rough idea of what I'm after. CogNarr has many use cases. If CogNarr were successful, it could be ubiquitous in social life. So a group, and there again could be all kinds of different groups, many different groups, defines a group event, its topic, its purpose, how decisions were made for this event, what kind of methods and rules will be used. The group then invites people to participate, and communications in this for this group event could be many to many, many to one, one to many. I have examples of all of these in the paper, but and I'll go over a couple shortly. Use cases could be decision-making, customer service, emergency reports, public polling, instructions on how to build a shelf or something, how to run a machine, system descriptions of how this system works, educational use cases, and more. And the later versions of CogNarr could include role-playing, strategizing. Here's what I believe. Here's what I think my competitor believes, and I'm going to do this. What would my competitor do if I did this? Or all kinds of various versions of strategy. How do I get the girl? Should I wear a suit and tie? Should I wear jeans? How should I act? Like whatever the issue is at hand. So this is an example use case for decision making that I've written out a little text here, but obviously this would be passages that a user is inputting into the system, and a graph is being created, as passages are implemented. So this person says, whatever this issue X is, we better first address issue Y that caused X, and issue Y started when blank, and it has the effect of blank, and if we don't solve Y, then we can't solve A, and this is likely to occur if that happens, and just on and on and on about some kind of conditional story, complex conditional story. And in this kind of setting where it's group decision making, what could occur is that at the top of this graph here, story input and editing, there could be 10,000 users or something, 10,000 members of this group. They each create their story, and the system would be helping them create the story too, to make it easy. And then after, say, the first round of input, the system would perform a bunch of computations, assess what the variety of different stories are, report back on how stories cluster with each other and all kinds of other things, story quality and story components and all kinds of things, so that the group can better understand what the picture of all these stories is. And then there would be opportunity for group dialogue, feedback, story digestion, asking questions, users asking questions about different other people's stories. And then after that is finished, then we can go back to the beginning and users see everyone's story and all the results of assessments. And then maybe they want to change their story to reflect what has been said. Maybe I'm involved in this group, and I put down my story, and then I eventually get to see what other people are saying, and I think, oh, that's a good idea. I want to include that piece in mine. I like that, or I don't like this, or I'm going to comment on this one of this part of this guy's story. So over a series of rounds, the idea is hopefully that the belief of the group would start to coalesce around core models. Maybe one person's story really captures the group sentiment, or maybe the group as a whole, the synthesis of their stories captures the group's sentiment. And over a series of rounds, the thinking of the group, the belief model of the group, starts to coalesce around central themes. And then there could be voting at the end. Various kinds of voting would be possible. Another use case is emergency reports. Again, this is a text passage, but it would be formed into a story graph. But somebody might say, hey, I might call a utility and say, I just witnessed an accident near this intersection. A large truck began swerving. It was wet, shouldn't have been going so fast. There have been many accidents at the corner, as a kind of an aside. The truck hit an electric pole, the wires started sparks in the grass. There's a school nearby. All of this, there's all kinds of implications about this story, right? The implication is that there's some kind of danger. Maybe the operator should send a fire truck, ambulance, send the police, something like that. There's implied dangers to the utility workers. This is just a short little paragraph, but it's actually quite rich, and there's opportunity for many kinds of. There's quite a lot of information that can be inferred from this little story that isn't said explicitly. In the second paper, I list a desiderata of about 20 aspects of what a meaning representation should be like, or should be capable of doing. I just list a few here, but it should be graph-based to be amenable to computation. Should be capable of handling document-length stories. The equivalent of, say, a few pages of text, or maybe even a chapter of text in a book or something like that. And should be able to handle a wide variety of linguistic phenomena. Should be reproducible in the sense that similar stories should make similar graphs. And there's more and more and more. Components should be compositional and reusable, and more. I won't go into any more detail on that, but there is a whole list of requirements. So the last couple of slides are just sort of fun to think about how some of this might be done and what might happen in the future. Are there applications of category theory here? This last paper on group interactions, belief sharing via sheaf and topos theory, I think is actually might be quite appropriate, because that's exactly what is happening in this group setting. The group is sharing their belief models. Those belief models are they evolve according to how the group thinking is going. They're unifying, or generally the group would be unifying around one or a few stories. And I think all of that could be studied mathematically. using some ideas from category theory. But also in category theory, one of the ideas of category theory is to reduce the complexity of a project or a system. So that's important because this is obviously a complicated system. C-set property graphs might be a basis for story graphs. Functors might be allow for graph to graph, graph to text, and other kinds of transformations. Some ideas from category theory might allow us to zoom in and zoom out. If you can imagine some very complicated story graph, but the user just wants to focus in on just one little piece to verify that the system understood him or her correctly. And for that, you might want to do a kind of a zoom in or zoom out summarization of some more complicated components of a story graph. So there's applications for category theory, and there's, I think, applications for Friston's From Pixels to Planning paper on renormalizing generative models. That I think there's potential there too, because a graph really represents a path, an evolving path of the graph itself is evolving, right? It's like a movie, as I said earlier. And so the renormalizing approach might be potentially useful there. And there's many opportunities for agent-based agentic models, for example, group members understanding each other's beliefs. So that's about it. Yeah, and again, the project page has all kinds of information about this.
Thank you, John. Ian, if you have a question, otherwise I can read one from the live chat.
Oh yes, maybe a quick one before the live chat. So it's a lovely optimistic sort of view that every member's story can be heard and understood and contribute to the collective, and it's sort of making me think about citizen kind of involvement in cities and knowing what issues are important to a community. Then is there a way that it can help with sort of this perennial issue of top-down opinion and bottom-up needs and wishes? So how would you weight, let's say, the stories from opposing members,
right,
of a group, if there's
right,
that sort of power
so there's the bigger issue that around what you've just said, and that's how do you keep this whole thing to actually represent functional cognition? And obviously, if one party has enormous power and another party has little power, that's the cognitive process is not going to be functional. So it quite clearly a lot of work would have to go into the design of this to prevent one party from dominating the entire discussion, for example. And there's a lot, and work would have to go into preventing hijacking of the process for some dysfunctional means or purpose. But some of that is quite addressable. So it should be. It seems to me that it would be quite possible to create a system that is fair. If everyone has only one voice, that's one way to prevent one person from dominating the discussion. That is, on a very simple level, if there's not bots, if a person can't create imaginary bots to be broadcasting their version of what should happen, then the person would only have one voice. And over time, maybe a group would get to know its members a bit, and some members would be more respected than others just naturally because they've contributed in the past, they've had intelligent things to say, they are experts in this field or whatever. So we only have a minute here, so I can't go into much further of how that would, the ways that kind of fairness and transparency and all that kind of stuff would be addressed. But I would think that there's many opportunities to do so.
Thank you, John.
Thank you.
Awesome presentation, and looking forward to continuing the collaboration. So, see you.